Okay, in this video we are going to examine how to write the equation of a line on the coordinate plane. So really when we're writing equations of lines on the coordinate plane, we have two main forms. And the first one is slope-intercept. This is probably the one that you are the most familiar with, and that is just y equals mx plus b. All right, in this case, we know that the m represents the slope, and then b is just my y-intercept. All right, and then the important thing to note, guys, is that the y and the x, xy, for every point x comma y, that is just a point that falls on the line. So x comma y, that is a specific pair, a coordinate pair that falls on the line. And then point slope form, this one maybe is not used as much. However, it's going to be really important, especially in calculus. So point slope is y minus y1 equals m times x minus x1. And later on in the year, we are going to work with transformations. And that is exactly what this equation here is based off of. Is transformation. So this m right here, again, still refers to our slope. And then that pair x1 comma y1, this just refers to a specific point on the line. Okay, it could be, again, any point on the line, but this is some specific point on the line. And then xy, just the pair x comma y, again, will just refer to all of the different pairs, all right? All of the different pairs of points that fall on that line. All right, so all we need in order to write the equation of a line is a point and the slope. All right, it doesn't matter what that point is. If it's the intercept, great. It's super easy to put it in slope-intercept form. If not, then we could just use point-slope form and even convert point-slope form into slope-intercept form. So here we want to write the equation of the line perpendicular to y equals negative 3x plus 5, and it goes through the point negative 6, negative 3. So in this case, we want it to be perpendicular to this given line. Well, parallel needs to have the same slope. You might remember that for perpendicular, it has to have the slope as the opposite reciprocal. So we immediately know that m is equal to the opposite, so it's now positive, and then reciprocal 1/3. So positive 1/3 is going to be our slope. Now here we are just given another point. Let's just say, all right, let's use point slope form. So let's call this the point x1 comma y1. And then we'll just plug in. So we can say, well, y minus y1, so y plus 3 equals 1/3 x minus x1. So x minus negative 6 is x plus 6. Okay, and then if we want to really just solve this for y, we could subtract 3 over to the other side. So y equals 1/3 x plus 6 minus 3. All right, it's also possible. What we could do is say that we needed to have it in slope-intercept form. At this point, let's just distribute the 1/3 and simplify. So y equals 1/3 x plus 2 minus 3. Well, that gives us, it has to be y equals 1/3 x minus 1. Okay, 1/3 x minus 1. Another way that we could have gotten to that same exact answer is we could have said, all right, well, starting in slope-intercept form, I know that we have y equals mx plus b. My goal is just to solve for what b is, right? I already know what m is. So y equals 1/3 x plus b. And then I'll just use the point negative 6 and negative 3 as an xy pair to solve for b. So I'll plug in negative 6 for x, negative 3 for y, and then I can solve for b. So negative 3 equals 1/3 times negative 6 plus b. So negative 3 equals negative 2 plus b. Then I'll just add the 2 over, and I get b equals -1, which is perfect, right? Then I'll just take that and I'll plug it right in up here for b. So I have y equals 1/3 x minus 1, which is the same exact thing that I found using the point slope form and then just distributing and simplifying. All right, so either way works. If you left this as your answer too, that would be totally fine. It really matters if it's specified as it needs to be slope-intercept form, then obviously leave it in slope-intercept form or get it to slope-intercept form. All right, last one. Let's write the equation of the line through -2, 4, and 3, -6. Well, I know that I need the slope and a point on that line, so let's get the slope. All right, so change in y's, -6 minus 4, over change in x's, and I'll show that I'm solving for slope here using m equals. So 3 minus a -2, which is 3 plus 2. -6 minus 4 gives me a -10. 3 plus 2 gives me 5. -10 over 5 is a -2, so I have my slope is -2. All right, and now I have two options, right? I could either use point slope form or I could use slope intercept form. I'm gonna use point slope form. I think that it's easier. And you can use either one of these points as your x1 comma y1. Either one, so it's really up to you. Okay, so I'll do y minus, let's use this point. Y minus 4 equals -2. X minus a -2, so x plus 2. All right, and this right here could just be your final answer. Say that I wanted y to be by itself. Well, I'll just add the 4 over to the other side, plus 4. All right, say that I wanted it in slope-intercept form. Let's just distribute. Y equals -2x minus 4 plus 4 gives me plus 0. So that's the same thing as just y equals -2x. Okay, let's just use, the other method where we wanted to just solve for b. So y equals -2x plus b. And I'll use this point right here. Okay, so plug in. -6 equals -2 times 3 plus b. So -6 equals -6 plus b. I add 6 to both sides. I get b equals 0. So I plug that in, and you're left with y equals -2x. All right, so really two different ways of solving this. No matter what, you are going to get the same answer. So hopefully this is kind of ringing a bell with you guys. It's bringing up some of the past math that you've done, and best of luck as you move forward with this.